Welcome everyone. This is another episode of On.NET, a weekly show where we discuss all things .NET with the .NET team and guests. And today, our guests are Pablo and Francisco from PlasticSCM. Hi guys, why don't you introduce yourselves and tell us a little bit about your company and the product you're developing.
Hello, Bertrand. Okay, my name is Pablo Santos. I'm the CTO and founder at PlasticSCM. We develop a version control system, and I'll let Francisco do a very quick intro about the company.
Hello, this is Francisco. I don't want to really take much time, but our company is Cody Software. We have been in business for the last 10 years. We have two products, PlasticSCM, a distributed version control, and Semantic Merge 2.0 that we launched a few weeks ago, the new version. And our customers range from very small companies, even individuals, to large corporations. We are headquarters out of Spain, and we have distributions all over the world. Most of our customers are in the US, and most of them are .NET based. To name a few, we have even Microsoft, we have Delphi, we have Navy, NASA. We have a lot of game developers that use large binary or large assets in their code. We have Samsung, we have Medtronic. In all the sectors, we have customers on a worldwide basis. So I leave to Pablo to start the conversation about why we use .NET, what is the foundation of our architecture, and how these architecture scales up to the cloud, where we launch a product just at the beginning of the year based on Azure. Okay, Pablo, to you.
Okay, so well, as Francisco was saying, we started working on .NET 11 years ago already. It was back in 2005, and we wanted to create a better version control system. By that time, the standard was mostly Subversion. Git was not even started when we started the company, although it was almost at the same time. And then we wanted to have something like, more powerful than the existing tools, but also easier to use. And at that moment, we knew that we needed to go for something multi-platform because, you want to come up with a serious tool for developers. You need to be multi-platform. And we made an investment at that time, or a bet, if you want to. That is going for C#. We like the language much better than Java for, well, not all very technical things, but also the feeling of the language and so on. So we wanted to go for .NET. Mono was there, so we said, okay, why not go in that way and trying to go for Mono and C# and also .NET and Windows and so on. And that's how everything started. Since then, it's been really a lot of work and a lot of different things. I mean, it's been 11 years already, a lot of releases, like almost 800 releases since we started. We do a release almost every week, not every week, but almost every week. We try to do a public release and so on, and it's been a lot of work there, right? And at this point, we have a working server that works on Windows, of course, Linux and Mac, and we also have GUIs and command line tools for all these platforms. And when I say GUIs, well, command line is okay, what you can expect for a command line. I mean, it's not something super fancy. Of course, it must work and must do the job well. But then we have GUIs for the three platforms too. We have native GTK-based clients. We have a Windows client, and we have also, based on Xamarin, OS X rich graphical interface, because version control is one of these few tools that need to be run on the developer workstation. I mean, you cannot do the entire thing cloud-based because you need something on the client side, right? On the user side. And then from there, we also move to the cloud. We released, as Francisco said before, a cloud server a few months ago. And from what I want to share is basically our .NET development experience, right? And the very good thing for us is that based on the same code base, we develop all these different things. I mean, we can run a server on a Raspberry Pi, and we can run 90% of the same code on a super big enterprise server, and then also 90% of the same thing it's running on Azure, on the cloud, scaling a lot, using big databases, cloud space, and and all that. And well, that's the story I'd like to share a little bit of the details.
Great. I guess one of the questions that everybody has on their minds watching this is how does it compare to the current king of the domain, which is Git? You said something earlier about binary assets, for example, and that sounds very interesting.
Exactly. When we started, Git was not still there. It was launched also in 2005, so few months after we got funded and we started, Git arrived. So it was really a competitor to watch, and we always compare ourselves to Git, which is everyone knows it. I mean, it's pointless to me to say that because everyone knows about it. How we compare? Okay, Git actually has been a great help for us. Why? Because when we started, one of the core things we tried to evangelize about was doing branching. A lot of branches, a lot of branching, a lot of merging. And at the very beginning, we had a hard time explaining to people, because a lot of people was on Subversion and said, do you want to branch per task? I mean, are you crazy? It's not the way to do it, and so on. Years later, at this point, we never have to convince anyone about that. I mean, they want branches, and we provide branches, so that's not an issue, right? So that's thanks that we have to really thank Git for that. Then about the direct comparison between the two. Well, we do very well with big binary assets by design. So we have a lot of customers on the gaming industry, game developers and so on. They need big assets and so on. We provide a lot of graphical tools. I'll show you later on a little bit of the tool just in action, and you'll see that we have a very nice visualization, which is what we call the Branch Explorer, which lets you browse the entire repository history very visually. That's one of the cornerstones of the product. And then we also focus a lot on merging. We put a lot of effort on the merge algorithms. We are even better than what Git is. Of course, there are not features for probably every team. Not every team needs them, but lots of teams will really benefit from them. And we also put effort on the client-side tools. I mean, not only the client, the visualizer, the GUI, right? But we also provide three-way merge tool built in. We developed Semantic Merge that is, is capable of parsing C# code. Then you can merge based on that, and then we provide like the full package, right? The entire package there, which is very good for the developer. So going straight to the point, how we compare to Git. We are better with big files. We are very good with big projects. We put a lot of effort on usability and GUIs, and we also try to make everything available out of the box, right? It's not like, okay, now you plug a three-way merge, now you plug another GUI. No, we develop the entire thing. It's, of course, from the development perspective, it's very challenging because you have to do a lot of things. I mean, we do server code, we do client code, we do web code, we do a lot of stuff, right? But that's the beauty of our project too, because there's a lot of things to do.
Plus the security.
Yeah, plus the security, as Francisco mentioned, which is, I mean, we have a lot of companies, a lot of customers on the enterprise, and they need very fine, a very precise way to tune security. So we provide access control list tackles for every single object on the system, and that's a key point.
What about, Git has one aspect that is quite popular, which is the distributed aspect of things. So how does it compare in that regard?
Okay, that's a very good question that I forgot to mention, so that's good. So at the very beginning, back in 2005, we started being centralized, client server, that's all. But only a year later, we added the distributed part. So at this point, and it's been like this for years, Plastic can work centralized or distributed on the same team. I mean, for instance, suppose a game development team. You have artists, and they work mostly in Subversion way of working. I mean, checking directly to the server, no replicas, no local clone, and that's something artists normally prefer because it's slightly simpler. But developers prefer having the local repo. I mean, sure. So we provide that too. I mean, it's not like an add-on or something built in by design from, I wouldn't say day one, but day two, right? So you have you can work centralized, you can work multi-site. Like I have 2 sites, so you only have 2 servers, for instance, and then 2 central teams on each, and then they replicate. You can have that. And then you can also have repositories on each developer machine, as Git will do. So we provide like the 3 things. In Git, for instance, although it's extremely powerful, right? But you are forced to always go for distributed. You can work centralized. I mean, there's the centralized concept of having a central server, by the way, but it's not like you cannot directly check in from your workspace to a remote server. You must check in locally, then push, right? We can avoid that step optionally. And in our experience, as I said before, developers prefer distributed. In some teams, especially in some big corporations, they prefer centralized, but some of the teams move to distributed, and then we have like all the options in between. And then in distributed, we add a few nice things, especially for very big repos. Like we can do partial replica. What I mean by that is I can take a branch and replicate only this branch and not all the history backwards. I mean, it's not like in Git you gotta change. I mean, you can specify the depth, all that, right? But normally you replicate from one commit and then you go back all the history to the very beginning, except if you specify the depth, but then you have some restrictions. In Plastic, you can say, okay, I only want this branch. You get a working branch. You can continue branching from it. You can push it back to the central, but you only have a piece of the history. I mean, even no history, just a single change it if you want.
So I have another question about Git, and then we can maybe go back to your product and look at specific aspects. But what about interoperating with Git? What I mean by that is, say I have a big project and I would like to open source some of it, and of course I don't want my contributors to have to install a new version control system, and I would like to give them access to at least part of the repository using Git. Is that possible?
Yeah. Exactly. Well, I mean, Git is a standard, right? So we know that. I mean, there's no point in arguing that. So what we did is to try to make it as simple as possible to cooperate with Git. So we have 2 ways of working with Git. One is you can turn every Plastic client into virtually a Git client. How? You can have your Plastic repo and then push and pull to a Git repo. And it's not like a conversion or something. I mean, basically, the Plastic client speaks the Git network protocol. So you pull from Git, you transform the commits on Plastic format, but the underlying format is not exactly the same, but similar, because we are both chain set oriented. We can handle merges in basically the same way. So you can do that, right? And then there's a second way of working, which is, so as I said, one is every Plastic repo can push-pull to another Git repo. So you can use your Plastic as a client of a GitHub project, for instance, if you want to.
So in that case, your Git clone that you have somewhere just acts as one of the clones in your distributed version control.
Actually, exactly. I mean, that's one of the ways. I mean, suppose we are both working on a GitHub project. You can be working on Git, and I can be transparently working in Plastic. I just push from my Plastic local repo to the Git public repo. I mean, on the client, all I have is Plastic, but for you, it's like if I were on Git. And then there's a second option, which is every Plastic server can be converted into what we call a Git server, which means a Git client can connect to the Git server. So it's like the same thing, but on the other side, right? It's like the opposite, right? So this is how we cooperate. Besides that, we support fast import and fast export, right? So in practice, what does it mean? You can have a team with a few developers on Git and a few developers in Plastic, because you suppose you want Plastic because some of them need the GUI and the tools and so on. You can have that. Or another scenario, you need a Plastic server because you need very visits. So you put a Plastic server, but part of the team is still on Git, no problem. Or it will be on Git forever. Okay, no problem. You can push and pull there. And the things that we contributed to leave Git to sharp long ago, because that's how we implement our stuff. And it's not like a conversion or something. I mean, we really implement the network protocol. So it's like for Git, it doesn't know if it's talking to a Plastic client or a Git client, and vice versa. I mean, you can have a Git client doing pull from a Plastic server, transparent. And that's basically the thing. We put a lot of effort on that because, as I said, we don't see Git as much. I mean, from technical point of view, it's a competitor, but from a business point of view, it's not much as a competitor, but as a complement, let's say, because we don't usually compete with Git. It's more like, okay, they have both. Okay, let's live together. That's all. Okay.
Okay, great. There is one thing that you mentioned that in passing, but I think it probably deserves a little bit more in-depth discussion, which is the semantic merging.
Yeah. Okay, that's one of the that's one of the ideas we always wanted to implement, but it took us a few years to get to the point where we could afford really going that path because we had to cover all the basics before in Plastic and so on. Then, what we did is the following: we developed a tool. There's a separate tool, of course, in the same space. Of course, we are always on branching and merging and versioning and all that, right? But the semantic merge is a three-way merge tool. So it's like, you can compare it to Beyond Compare or Axis or something like that. It's a standalone three-way merge tool. You can plug it to Git, but it has a difference, especially for C# developers and Java and so on. But C# is really our core, right? And it does what every programmer expects, which is, okay, you parse the source code, then you merge based on that. It's not rocket science. It's just, it was not very widely adopted before, and that's it. So what's the advantage there? The advantage is very clear. Suppose you refactor some code. We are both working on the same project on GitHub, and then you touch some code and decide to move some methods to different locations because you prefer privates to be down, right? That's okay. And then I modify the methods on the original location. For a regular merge tool, it will be normally a nightmare because it will try to match the methods line by line, and that's hell. But Plastic, what it does, semantic merge, what it does is very simple. Is okay, I merge the three contributors. Sorry, I parse the three contributors, and I merge based on that. So if I have method calculate, I know it's method calculate. I don't care whether it's on line 20 or line 200. I know it's that method. So I diff and merge based on that. And that's very powerful. And then we just released Semantic Merge 2.0 like 1 month ago, and officially, and I think it's not even 1 month. And it's like Semantic 1.0, it's been on the market like for 2.5 years or something like that. And 2.0 is like a step beyond, a step forward, saying, redesigning the GUI and making it much easier. The version 1 was a little bit alien because we screened this way of merging and finding how to show the information to the user and trying to do our best making it simple. So we came up with a GUI that showed only the conflict. Now in 2.0 you have the three-way, you have the 3 panels with the 3 files, and you merge on text mode, but with all the semantic power. While the version 1 was a little bit more, different. So we expect this to be much easier to get used to.
So it feels like the text-based three-way merge tools that people are used to, but it bases its decisions on diffing the syntax trees rather than text.
Exactly, and it decorates the text with this information. So suppose you have a move method. It will show you a line saying the method was moved, and you see the icon on the proper location, and it will be able to compare, and even it's able to like break the scroll and put the methods together to diff them, even if they are on different places, right? It will just put it side by side, and then it's very easy to diff.
Can they even be in different files if you move something from one file to the other?
That's a very good thing. We don't have that yet on Semantic Merge. But we have this built in Plastic for diffing. We have a feature called Analyze Refactors. And basically what it does is you go to a branch or a chain set, and you show the diff, and it shows you, okay, 4 files have been modified. And then you click on Analyze Refactors, and it's able to track code that has been moved from one file to another, shows you a diagram saying, look, this code has been refactored, and so on. And that's very nice. And the thing is that the next step is to apply it to Merge. We have some prototypes. I mean, we've been toying with prototypes of what we call multi-file semantic merge for years. The thing is that at this point, we need a little bit of more. I mean, we have like a few prototypes for Plastic, integrated with Plastic, but we never release it like for every other version control, because to plug a new three-way tool is very simple. You just put it on Git, for instance, or Subversion, whatever, and you specify 3 files, and that's all. You get a merge. Yeah. But in order to do it semantic multi-file, you need to get access to all the files in merge being processed. So the standard interface is not enough. So you need to make a modification to the way in which the merge is launched. So that's the thing holding us to actually launch it. So we are on that. I mean, we expect to do it on the coming months, but I've been saying that for a while, so I don't have the exact date. I mean, it's not. It's mostly a usability thing more than a technical thing, because I have videos showing the multi-file merge for years, but we have to figure out the right way to present it to the user. Mm-hmm.
How about how about a demo, maybe?
Yeah, I can show you some of these things in action. So if you want to, what I'm going to do is I will share my screen and show you a little bit of Plastic and Semantic in action. Sounds good?
Okay, sounds great.
Okay. Okay, so let's go. What you're going to see, I think we are, okay, I'm already sharing. You can confirm that. So what you have on the screen is Plastic, right, at this point. And what you have now, what you're seeing now, is what we call the Branch Explorer. This is the visualization, the main visualization we use to browse the repos and so on, right? As you can see, it's like the typical diagram for branches that you draw on a blackboard. And that's it. That's basically the inspiration from the Branch Explorer, right? We started with that idea, and that's what we wanted to achieve. It's horizontal, and it's very simple to follow what's going on. So you can go, and the good thing is that the diagram is not just a static thing. It's something dynamic, as I'll be showing in a second, right? You can click on a chain set. Well, these bolts, these ellipses are chain sets. You can click on one of them, right-click, and say diff chain set, and then you go and you diff it. At this point, I'm showing an image file, so I don't have like diff here, but I will show you the same thing with some code. Okay, and then you see a small modification on a C file at this point, and you see that, right? I can do exactly the same thing for an entire branch. So I can go and diff this branch, and then I diff the entire branch. And then some of the nice things you can see here is that I can click on what we call semantic diff. This is built in Plastic. Then it calculates, and look at this. You see this interface gets decorated with a few icons, right? It's saying, okay, this method right selector has been moved, N stands for move, and change it, okay, well, modify, right? And then you can put it side by side, and then it does like this, and despite they are on really different, you see that, right? They are on really different lines, but they are just put one together with the other. Of course, it's a very, like, you know, extremely simple example, but it can go and do much more complicated stuff. But it's fine in this. And we can also do interesting stuff, like, for instance, we can go and do, okay, visual diff. So show me a graphic with that, and then show me everything. And then you get the diagram explaining what happened. And then you see the right selector was moved down. I mean, by the way, in this example, you don't need all these tools because it's so simple, but it shows you an idea of what it can do, right? This is semantic technology built in Plastic. So what we did is we developed Semantic Merge, then we have Semantic Merge as a separate standalone product, but we also got some of this technology and put it standard on Plastic. So that's a little bit about it, right? And then, well, about Plastic, well, one of the things I wanted to share is that all this interface you are seeing, all the server code, all the super fast and scalable server code is done in C#, and I wanted to share something with you, which is the gallery. I could show it in action on a VM, right? But a few screenshots will be good to look at this. This is a Mac client, so it's exactly the same look and feel. Well, the branch is probably the same look and feel. Of course, we try to come up with the built-in look and feel for the platform. In this case, it's Mac OS, and then you see, the same functionality but going to a different platform. Again, 100% written in C#, which is one of the things we are happy about it, right? Because the bet we made back on 2005 paid off. And then I'll show you the same thing on Linux. And you see, whoops, I clicked on the wrong place. No, sorry. So, and you see, this is sorry, I didn't click on the right one. This is Linux support. Now it's fine. This is GTK, right? So it's GTK based, different look and feel, same layout, but going really native on each of the other platforms. Every line of code is C#. So that's one of the things we are happy about it, right? The capability of really going multi-platform with the same code base. By the way, one of the things we learned over the years, and it's probably quite shocking, so it's one of the things I like to share, right, with all .NET developers, that first, we are not using designers visual designer for any of the GUI development. We started using WinForms long ago, and the typical designer you get on Visual Studio. We don't use that anymore. We build everything based on code. It takes a little bit more time the first time, but in our experience, of course, that's our opinion, and I'm a little bit opinionated about that. I might be biased, by the way, but we develop everything in code, so it's easier to maintain. You spend a little bit more time the first time, but then it's easier to maintain. And second thing is that for years we had exactly the same code base using WinForms on Mac, Linux, and Windows. But now, like 3 years ago or 2.5 years ago, we split the GUIs, and we have a GUI for Mac, different GUI for Linux, different one for Windows. Of course, they share all the basic functionality, but the GUI part is different because it gives us more freedom to do slightly different things on each of them, right? So it's a very thin layer. It's not like a big thing. It's a thin layer. It's not super thin, but it's not super thick either. And we have different layers on each operating system. And we even developed something very interesting, and we have some videos on our YouTube channel. We developed our own GUI testing tool, very thin layer on top of Linux and Mac too, Xamarin and Mono, and it's able to automatically test the GUIs. We rely, of course, a lot on unit testing, but we do a very thin layer of graphical tests. We use Test Complete, which is a commercial product on Windows, but since we didn't have a proper solution for Mac and Linux with C# code, we developed a very thin layer to test that. Right. So that's a little bit of focusing on more than the product side of things, more the the development side of things. And then, well, in Plastic you can do a lot of things. I mean, this diagram is not only about viewing differences. You can go and do something like, okay, right click on a chain set, create child branch. You create a child branch, you give it a name like backfix, I don't know, something like this. You can put it a comment for the branch, fix back. Okay, I wouldn't put this comment in real life, but let's do it for the sake of simplicity. Then you get the new branch created. You already switched to it. Okay, I have a lot of space there because it's a very small branch, but otherwise it wouldn't be like that. And then I already switched to that, and then I can go and make changes whatever I want. What I'm going to do is to open it in Windows Explorer and look at this. So move this full file and put it on a different location. Go back to Plastic, go to pending changes, and Plastic detects the move. One of the things we do very well is detecting the move. And you might say, okay, but you only moved a file. That's not a big deal. Let me show you something else. I can go back to Explorer, and I do that. You can do all these movement, all these operations. You normally do them inside Visual Studio. So we have Visual Studio plugin. Everything is hooked inside Visual Studio, so you don't end up having to detect moves or anything, because Plastic knows that Visual Studio did the move, because basically Visual Studio said that to Plastic. But what I'm trying to show you this way is what we call transparent version control, which is, suppose you don't have a plugin for the tool, or you work on that way because you prefer working without plugins, which is, for instance, how I personally work. And you can go to your workspace, your working copy, just where your code is, and then you can do interesting things. For instance, suppose you do this, library renamed. Okay, you go back to Plastic, you go to pending changes, you refresh, and then you see it detects the move on the directory. Why I wanted to show you that is because you were asking me about differences with Git. One of the key differences between Plastic and Git is that Plastic tracks directories. I wouldn't, it's a design decision, right? I wouldn't argue, okay, in my opinion, of course, it's better. I wouldn't argue with Linus Torvalds himself about that, because I know he's very opinionated, but you know, one of the very nice things we do in this case is that here you see a single rename. You do the same thing on Git, you get hundreds of renames, because every single file is set to be renamed. We track it this way, we track directories. It makes a few things in the implementation more complicated, but then you get all this beautiful stuff. And then you can go and check in, right? Just go, check in, and then you create a new change set. You're in the branch explorer, you see your new change set. And then from here, if you have time, I can show you a small, very quick branch and merge process. If you want to see that,
sure.
Okay. I'll try to do something complicated but fast, right? Like show you the most complicated merge case in a second. So what I'm going to do is, I normally work with a sample file, which is what I call file system. I'll open it up. Well, I use a very old Visual Studio for demos because it's very fast to open files and so on. And then what I'm going to do is this, right? I take this open directories method, and I'll put it down.
You know we have VS Code now.
Yes, I know that, and I normally use it, but I should be using that instead. You're right.
Yeah, that looks
using
like
more
a
on
very
Mac.
nice copy of Visual Studio indeed.
Yeah, well, normally I use, you know, for the real code, because I was working on a task before joining the meeting. I'm using a newer one. I always use this like a notepad or something. Okay, so I modify these methods, like methods modify, right? Then besides doing that, I'm going to show you something else. This is in common. I'll go again to the workspace. I'll go to common. I take my file system thing, and I'll rename it. I go back to Plastic, go to pending changes, refresh, and it's telling me, oh, you moved and renamed the file. And that's not actually true, because I just rename it. I mean, it's not like that, like it's deleted. One of the things you can do is search matches. And then basically say, okay, you know why it's not detecting it? Because it's 71% similar. Because, I mean, if you look at the code, it's a very stupid file. I mean, it's very short. So it, just a single move modifies like.
So when it
30%.
can't really, with great confidence, determine that something happened, it still gives you the choice to say exactly what happened. And interesting.
Exactly.
That's
exactly.
nice.
So I can say here, okay, it's the same file, so apply it, and now instead of saying locally moved, it's saying moved, because now you told Plastic, hey, I moved it, right? So we already make it, and I show you the diffs now. I show you the built-in diff. As you can see, one of the beautiful things is that we provide you with a built-in diff. It's a side-by-side, code colored, syntax highlighted diff tool. And I can do it in semantically, and then you see like an outline of the thing. You see an outline here with the methods and everything. And then you see the open directories thing, and then you can see the actual diff. At this point, there are not many diffs because I just moved the method. I don't know if I actually say, yes, I saved it. I mean, there's not like a big difference or anything. Actually, there's something interesting here because it's finding my open directories thing. Look at this. It's finding my open directories with the move code, and it's also finding the original one there, right? If we put it together, you just see there's the method down there. So next thing I will just check in. Oh, checking. And the next thing I'm going to do is to do something similar on another parallel branch. So second branch. Okay. Okay, here we go. Well, I'm going to diff the original one, and then I get this, and I get the moved. I get the move. Okay, I'm fine with that. Okay. So the next thing I'm going to do is to go back, find again my file system file, which is the pool file I always use. I say the pool file because it's getting all the changes, and I'll move it to a different location. Instead of common, I'll put it inside LCC CPP rename. Just there, right? Go back to pending changes. My file is now moved, as you can see here. Okay, so I'll just I will ignore this one. In fact, I can even delete it because that's coming from an older example. Okay, so I have my file there and it's being modified. Before leaving this file, I will reopen it. Remember, we modified open directories before. So what I'm going to do here is change it again. Save it. Go back to pending changes. Refresh. It's now change it and move it. It just shows me in 2 lines, but it's exactly the same one. And then I will just second checking. From there, go back to the branch explorer. And what I'm going to do is, okay, I can freely merge from this branch to this one to this one. I can do, I mean, there are no limits in how you can merge branches in Plastic. So, but what I'm going to do is to simulate like a release. And then what I'm going to do is to merge these 2 branches back to main. In order to make it a little bit more interesting, I'm going to show you what we call the sub-branches. Branch Explorer, show selected and related branches in a new diagram. I'll do that, and then, okay, I click on, let me do this. Show selected branches in a new diagram. So now I have a new diagram without all the other branches around. You see I have like lots of branches in my repo, lots and lots of them. So I just create a new one only with the branches I'm interested in. And then what I'm going to do is to switch back to main, which is equivalent of master. Okay, here I am. You see the home icon there. And then I'm going to merge the 2 branches back. I'll start with this one. Right click, merge from this branch. Very simple. You get a preview of the merge, which is something also very useful. In this case, I will just say process all merges, and I'm done. Okay. If I go to the branch explorer, you see now I have like a pending merge link, which means, hey, this merge is done, but it's not yet committed. If I go to pending changes again, I see the regular change, but I see the merge link ready to be committed. I'll just check it in. So first merge done, nothing difficult on the first merge. Oops, let me go to the, okay, now you see the merge is no longer like dotted or dashed, it's now like a real merge. And then I'm going to show you what happens when I go and merge the second branch. Right click, merge from this branch, and then you see the preview. And that's one of the key things in Plastic. If you remember, I went very, very quickly, right? But if you remember, we did something interesting to this pool file. In one of the branches, we move it to one location. In the other branch, we move it to a different location. This generates what we call a divergent move. And this is one of the strengths in Plastic. We are very good with directory merging. What does it mean? In other version controls, you will end up with 2 files. And then you will have to decide which one's a good one and do the merge mostly manually. In Plastic, it detects there's a divergent merge conflict. You can click on choose, and then you can solve the conflict. It helps you solving the conflict. You can say, okay, what do you want to do? Because it was on common file system, but in one of the branches you move it to common file system rename, and on the other one you put it under LCC CPP rename. What do you want to do? Preserve one or the other? Of course, later on you could move it once more, right? But you can decide. Before deciding, I will show you something interesting too, which is very good for training, which is what we call the explain merge. In explain merge, you see a smaller diagram explaining what the merge is about. This is the base, the common ancestor for the merge. This is the branch you are merging from, and this is the destination, which is where you are now. So it lets you understand the merge. I mean, this is a trivial merge, but there are cases where the base is very far away, and then it's very good to get this diagram. Okay, so what I'm going to do is decide one of them. I'll get the move to a different directory. I'll keep this one. And then once I'm done, Plastic knows the same file has been moved and modified. So it will launch the merge. Let me check my preferences to make sure I show you Semantic Merge. Okay, I want to show you Semantic Merge in action. So I will choose it. Because otherwise I can show you the default built-in merge tool. I'll click on Process All Merges. And then, okay, well, it's warning me there are some warnings on the file if I want to continue or not. Okay, I can continue with Semantic. And then here we go. You'll see Semantic Merge in action. Okay, well, I have to update my own version, but that's okay. And then you see the thing, right? Look at this. It's telling you, you have only one conflict to solve. Because the other one, the other stuff there, the move was automatically solved. And what you see here is, okay, remember the change? You have open directories on line 52 on the base, and one origin. Sorry, that's what it was originally. That's one of the contributor, and this is the contributor you are merging from now. And you get exactly the change. As you see, there's a conflict because you changed exactly the same line on the file, although the files are on different places at this point, right? In fact, I can do something very interesting, which is what we call the visual merge. Remember the visual diff we had before? This is the merge counterpart. You see the entire file, and you see what happened, right? I have open directories. In one of them, I moved open directories down, but in the other one, we move it to a different location. And it's being able to handle all that, right? So we do that. We can go and solve the conflict. I can click here and say, okay, merge. And then we do what we call a submerge. And then it's like a merge, but only for this method, which is normally much easier. And then you can decide here what you want to do. Like, okay, you know what? I don't want this contributor. I only want the other one, or just you can type or whatever. You're done with that, you solve, and you're done. And then basically the method was solved. And that's, you know, like a full cycle using Plastic. I can save and exit now. I'm done. All the other things that, like the renames of directories and so on, were directly applied. If I go to pending changes, I'm ready to check in. And if I want to the branch explorer or the custom branch explorer, I now see the other one. And that's a little bit about the power of what Semantic can do. And I wanted to show you something else. Well, I don't know if you have any questions in the meantime.
I do, but please continue.
Okay, I wanted to show you something, and I will use the, if you don't mind, I will use the our features webpage for that. We have something called built-in semantic diff, which is what you were seeing, plus analyze refactors, right? And this analyze, well, all the semantic diffing things what I show you already in Plastic. You can even do things like tracking crisscross merges, like the one I have on the screen right now on the website. You see a method move down, another one move up, it's cross, but it's able to detect the thing. And then we have something called analyze refactors. And look at this. When you diff a change set or a branch, it's able to find something called refactor group, right? And then in the refactor group, it says, look, the refactor group is built, is made of one file, two files, plus a rename. And then you see here what happened. You have a socket class and a socket file, right? And then it was split into a server socket and a client socket. And the code was moved from one file to another, and later change it, and Plastic is able to detect all that. That's one of the steps towards, I mean, we think that there's a lot of power in version control if we really try to understand, well, understand is a big word, right? But, you know, try to understand a little bit what the code is, how the code is done, because then we can show more things. Like we have a feature, for instance, we have a feature called method history. You click on a method and you see the history of the method itself, not the entire file. The other one is this analyze refactors. And this is part of the work we are doing, mixing the version control technology plus the semantic technology. And as I said at the beginning, remember I told you, well, it took us some time to get here because first we have to do all the, scalability, check-in, basic merge, multi-platform, all this stuff that people expect to have when you buy a version control, right? But once we develop all the basics, now we are in a position to continue developing more innovative stuff, like for instance this one, right? And that's basically what we are working on at this point, and moving forward with newer releases and so on.
Very nice. So even though we are a show about .NET, we also care about a few other languages. And actually, it's not just C#, even in .NET. Do you have support for F#, for example?
We don't. We are parsing with Roslyn at this point. Mm-hmm. So for .NET, we are using Roslyn. So
which means you have VB and C#.
Exactly, but we don't have F# yet. Then we have support for Java, because we have a Java parser. I mean, we use one Java parser, and we also have support for C code using libclang. The thing is that you can plug your own parser if you want to. In fact, we have customers that plug Delphi. There's even there are pluggable parsers to support Delphi in Semantic and Plastic. And our goal is to keep moving forward with more and more languages.
You have JavaScript?
We have JavaScript. There's a funny thing there. We don't have it like out of the box with the product, but it's downloadable, and you can get it after that. Depending on what flavor of JavaScript, well, not flavor is not a good way to say that. Depending on the style of JavaScript you use, you'll get it. I mean, if you use like methods and classes and so on, then it's going to be useful. If you only have like a few big files with code there, then it's not very useful, because as you saw, Semantic is all about code structure, like methods and functions and properties and stuff like that. Right? You don't use this way of working, then it's pointless. See what I mean? Yes. Right?
Yeah, but you could do something with functions.
Exactly.
That is very similar. I mean, the nesting is a little different, and the structure tends to be different, but it's still functions. So
exactly. So if you use it this way, I mean, with all this, with this way of working, then it's perfect. Now, if you look at the screen, I'm showing some Java code, and we also have like the semantic theme for it. And in fact, I'm going to show you the analyze refactors instead of on C# code, on Java code, and it's exactly the same example. You see that? We have the socket thing, and we have the client socket thing, and then you can go and see how the code was moved from one side to the other, and then you can go inside the methods.
So can you actually drill from the diagram into the code, or? Sorry,
can you?
Can you drill from the diagram into the code? Can you click on one of the little M's, for example?
Yes, you can click and see different. For instance, in this case, let me show you one of them. I can click here in RecV, for instance, and it will show you that the method, in this case, the method was only moved, not changed, right? But it was moved from one file to the other one, and you can track it this way. Yes. So these are some of the things. I didn't cover the cloud stuff. I mean, we have a server in Azure. We also have replication. I mean, every single branch you can do a replication, and then push this branch, pull this branch, or sync it with Git. You can push it or pull it to a Git server, and that's, I could be talking about this for hours, but that's like what you can expect for the way of working with distributed and so on.
Very nice. Yeah, I think that's a nice introduction to the system, and I'm sure it will. A lot of people seeing that will want to try it for themselves. And speaking of which, how is your pricing structured?
Well, we have basically two different editions, right? We have one that is more like for enterprises, for big teams, what we call enterprises bigger than 15. And then we have a price per user for a perpetual license that is like around $500 and something per user. And then we have team edition, which is for smaller teams, less than 15 users, developers. Sorry, they don't need some of the high scalability things that we pack on the other server and so on. And then it's $9.95 per user per month. And then we also have cloud support, which is up to 15 gigabytes for only like $15 per team. And we have another edition, which is like cloud only. Instead of having to host your own server on your office, it's like only local repos plus cloud. So very Git-like if you want to. And then the price is even cheaper. So we have like three levels, like for teams that only need like pure cloud, teams that need cloud plus centralized on the office or something like that, and then enterprise. There's one thing that we are very excited about that I would like to share, right? That is, we are right now working on a port to .NET Core. We are very, very excited with .NET Core. I mean, after all these years in Mono, which of course is wonderful, right? Like having like official Mac and Linux support from Microsoft is like a dream come true. I mean, since 2005, that's what we expected to happen, right? Basically. So we are working now on this port. And we expect to have, of course, the GUIs will stay on Xamarin and GTK for a while because it's not like an objective for the project at this point. But the server side will greatly benefit, I think, from .NET Core and also the command line tool eventually, right? We're going to start with the server. We'd like to have a .NET Core with our server running on .NET Core, even with a native compilation that was on the previews, but it's not there. And now on 1.0 release, but it will come soon, as far as I know. So we are very excited with that.
Very nice. Okay. Anything else you want to mention about the product?
Well, one of the things not specifically about the product. I mean, I think it's very good for every .NET developer to check it out and take a look into it. But what I would like to say is that we are open to share our experience with any team and any developer who's interested in, cross-platform .NET development. We did a lot of stuff over the years, and we've hit a lot of issues and also learned a lot of stuff over these years of development. So we'll be more than happy to share, the things we learned so far. So they can reach us by email or Twitter or whatever. I'll be more than happy to try to share our experience. Won't be always right, of course, but it's the things we learned over the years. So, yeah.
Do you have a blog maybe where you share some of that?
Yeah, we have a blog .plasticscm.com. We share some of the experience there, and we are about to start a series talking about cross-platform. We also shared, for instance, how we develop Semantic Merge on different platforms a few months ago, but yeah, we'll be sharing most of the thoughts there. But even beyond the blog, I mean, if someone feels like asking some specific question, how did you guys did that, or why did you do this way, and what you learned, or what you did wrong, we'll be more than happy to share it.
Okay, I'm adding the link to the blog to the description of the video, so people can check it out and subscribe. I want to thank you again for being on the show today, both you, Pablo, and Francisco. And thanks again, and we hope to see everyone again next week. Bye, everyone.
Thank you.
Thank you. Bye-bye.